everyone. So this is the lecture number 2 for our DSU series. In this video, we will try to focus on quick find and we will try to understand what this is and how it is better than what we saw in the last video. Okay, so the last video, one of the imperative issue with the find operation was that we needed to ascend continuously within the array to find the root. Okay, for example, suppose we had some hypothetical array, and to find the root for some specific index, we needed to go to this parent and then visit that parent and then visit that parent until we find that that parent is equal to the vertex itself, right? So it was some in some sense a continuous ascending. Okay, and it took an order of an approach to find just the root. Why order of an approach? Because in case if we have a very skewed graph, something like this, so if I have to find the parent of the root of this thing, I will have to go through the parent of that, and that, okay, until I find the root. So it was quite hectic. So in order to tackle that thing, now what do we have? We have the quick find operation. What it does, it will return me the root of a node in order of one time, in a constant time. And how it does that? We maintain a root vertex array. Initially, we had the parent array. Now we'll maintain a root array, and the index value will be the vertex of the node, okay? And the array value will be the value of the parent of that specific node. For example, the parent of 3, we can see is 0, and it is visible from this node itself that 0 is the parent of 3, okay? Now, let us look at the pseudocode for this thing. It is very direct, and it won't be an issue. Initially, what we'll do is we'll maintain a root array, and the root array in the start, it will every node will be a root node for itself. So that is what this line is doing. Create a root array where every node has a value equivalent to itself. Why? Because that node is still not connected, and that is the root of itself. Okay. We'll have the find operation, and this find operation, it will return in order of one time the root of the node. Okay. Now we have this union operation. Now, since this is returning in order of one time, that is why it is called as quick find, okay? But in this case, union operation will take time. And this is the pseudo code for the union operation, okay? What do we do in union operation? We find the root of the corresponding nodes that we have to union. And if their roots are not equal, it means that those two nodes are not connected, okay? Those two nodes are not connected, and we have to connect them. So in order to connect them, what do? We find the root for the second node, and we try to scan through the array, and in every part or every value of the array where the root of that value is equivalent to the root of the second node, we modify that to be the root of the first node. As simple as that. It might seem pretty confusing maybe, but it is what it is, okay? For example, in this case, suppose we have 0, and 0 is the root for all these nodes, and in this case we have 2, and 2 is the root for 4 and 6, okay, which is visible from the graph. As you come to 4, you see that 2 is the root. As you come to 6, you see that 2 is the root. As you come to 2, obviously 2 is the root. Similarly for 0, 1, and 3 and 5, 0 is the root, okay? But what will happen if I ask you, hey, can you please connect 1 and 2? Or hey, can you please connect 0 and 2? Okay, let us perform this operation, and maybe this part of the code, it will become clearer. I ask you, hey, let us connect 0 and 2. Okay, let us do that. What do? We are connecting 0 and 2. Okay, good. And I'm assuming that 0 is the root for node 2. Okay. Now, since we know that we are discussing quick find operations, and the quick find will return me the root for any node in a constant time. So what we'll do is we will come to 2, and we will change the root value of 2 to be 0, because in this case, I've assumed that 0 is the root node for this union operation. Okay. So I came to 2 and changed its parent value to 0, which in this case is a root. Okay. And I do not stop there. What I do next is I scan through the array, and every time I see that the value of the array is 2, which is like the initial parent node, I change that back to 0. Okay. So I come here I see that, hey, this is equivalent to 2, which is like the initial root, and I am changing the value of that initial root to the root of the current node, which is the 0. Okay, so I change 2 back to 0, and I also spotted 2 here, and I will change it back again to 0. And this is pretty much clear now. We see that initially we had a different root for 4, similarly for 6, but after this union operation, those roots had changed and those are now pointing to 0. And it is happening because we are dealing with quick find operations and we want to access the root node in a constant time for any specific node. Okay. For example, let me ask a question. Hey, is 5 and 6 connected? We come to the array, we see that the root of 5 is 0. All right. We come again to array, we see that the root of 6 is 0. Okay, so since that root is 0, 0, so we can say that, hey, 5 and 6, they are connected because the roots are identical. And we were able to, a compute is connected in a constant time once again. Right? Because why constant time? Because they are dealing with the find operation, and the find operation is the constant time operation. So yeah, that is what it was all about, quick find operations. And as far as this pseudocode is concerned, I would not say it is a proper pseudocode. It is much more of a Python code. But again, it is, since Python code is pretty much identical and readable, I hope you understand. You can ignore these words, self, 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 if you are from different language. But again, this is the core pseudocode or core structure of how quick find will look and how the union operation will look when we are trying to implement quick find. Okay. So yeah, that's it. I will see you in the next video.